Right now, as you sit or lie completely still, you are moving faster than a jet aircraft, faster than the fastest winds on Earth, carried silently through space on a journey you cannot feel. The ground beneath you is turning. The planet itself is spinning. And at the same time, Earth moves around the sun, drifting through the galaxy, pulled by forces so vast they are almost impossible to imagine. And yet, it feels like nothing. That is the mystery. Because if Earth moves so quickly, why does it feel perfectly still? This quiet contradiction is one of the strangest experiences in all of science. You are part of a motion so immense that in a single night you travel millions of kilometers through space. And still, your body feels at rest. On Velarin, Sleepy Space Mysteries, we once explored how the universe itself is expanding in every direction, gently carrying galaxies apart. But tonight, we come closer to something more personal. Not the motion of distant galaxies, but the motion of you, because every second of your life is written in movement. Every sunrise you have ever seen was not the sun rising, but Earth slowly turning you into the light. And this motion is not simple. It is layered, subtle, and constantly changing. Earth does not move the same way twice. The speed shifts, its direction curves. Its path through space is never repeated. Somehow, inside all of this motion, there is balance. A perfect stillness within constant change. But that raises a deeper question. If everything is always moving, what does it really mean to be still? And even more quietly, if motion never stops, what exactly is time? Tonight, we will follow this journey step by step. From the gentle spin beneath your feet, to the deeper motion through the cosmos, to the unsettling realization that time itself may not be what it seems. But before we drift further into this quiet mystery, take a moment to settle in. If you enjoy these slow journeys through space, consider subscribing to Velarin Sleepy Space Mysteries, leaving a like, and turning on the bell so you don't miss future explorations. You can also join as a member if you'd like to support the channel more deeply. And as always, I'd love to know, where in the world are you listening from tonight? Now, let's begin with the simplest motion of all, the one happening right beneath you. The simplest motion of Earth is also the one closest to you, and yet it is the one most easily ignored. Right now, beneath your feet, the entire planet is turning, completing one full rotation in just under 24 hours. This means that every point on Earth is being carried in a vast circular path, gently but relentlessly moving eastward through space. At the equator, this motion reaches a speed of about 1,670 kilometers per hour. Even at higher latitudes where the circles are smaller, the speed is still immense. And yet, your body feels completely still, as if nothing is happening at all. This illusion of stillness is not a failure of your senses. It is a consequence of something deeper, something quietly elegant in the laws of physics. Everything around you, the air, the walls, the ground, and even the molecules within your body, are all moving together at exactly the same speed. There is no difference between you and your surroundings, no relative motion to detect. And without relative motion, there is no sensation of movement. This is why you do not feel the Earth turning, just as you do not feel the steady motion of an airplane once it reaches cruising speed. But the stillness is only an illusion. If you could somehow step outside this shared motion, if you could hover above the planet and watch it turn, you would see something extraordinary. The Earth would appear as a vast rotating sphere, carrying continents, oceans, and clouds in a continuous silent spin. Cities would sweep across the surface. Night would slide into day, and the place where you are right now would trace a perfect circle through space. This rotation is what creates the rhythm of day and night, one of the most familiar patterns in human life. But even this simple cycle holds a hidden complexity. The Earth does not take exactly 24 hours to complete a full rotation. In fact, it spins once relative to the distant stars in about 23 hours, 56 minutes, and 4 seconds. That missing 4 minutes is not an error. It is a clue, a quiet hint that Earth's motion is not just a simple spin, but part of something larger. As the Earth rotates, it is also moving along its orbit around the Sun. By the time it completes one full turn relative to the stars, it has already traveled a small distance along that orbit. To bring the Sun back to the same position in the sky, it must rotate just a little bit more. That extra rotation takes about 4 minutes, stretching the solar day to 24 hours, the time we measure with our clocks. This small difference, barely noticeable in a single day, slowly reshapes the sky over time. Each night, the stars appear to rise about 4 minutes earlier than they did the night before. Over the course of a month, this becomes a shift of about 2 hours. And over a year, it completes a full cycle, which is why the constellations you see in winter are different from those you see in summer. Long before modern science, ancient observers noticed this quiet drift. They watched the stars shift night after night, season after season, and realized that the sky itself was changing. But the truth is, the sky was not moving. They were. The Earth beneath them was turning, carrying them through a changing view of the universe. And yet, even this rotation is not perfectly steady. It changes ever so slightly from moment to moment. Winds move across the surface, oceans shift their mass, ice melts at the poles. Each of these changes redistributes weight across the planet, subtly altering its spin. The effect is tiny, measured in fractions of a second, but it is real. The Earth does not rotate at exactly the same speed every day. This introduces a new layer to our mystery. If the most fundamental motion of our planet is not perfectly constant, then the time we build upon it is not perfectly constant either. The length of a day, something that feels so fixed and reliable, is actually drifting, changing in ways too small for us to notice, but large enough to matter in the precise language of science. So now we return to the question we opened earlier. If you are always moving, carried by a planet that never spins the same way twice, what does it really mean to be still? And if even the length of a day is not truly fixed, then what exactly are we measuring when we measure time? These questions begin here, with the quiet turning beneath your feet. But as we follow this motion further, we will discover that Earth does not just spin. It accelerates, slows down, and traces a path that is not perfectly circular, but gently stretched, subtly uneven, and filled with hidden rhythms that shape everything we experience. And that leads us to the next layer of this journey. Because the Earth does not move around the Sun at a constant speed. It speeds up, it slows down, and in that changing motion, something unexpected happens to time itself. If you were to step outside at exactly the same time every night and look up, you might begin to notice something subtle. The stars are not in quite the same place. At first, the shift is almost imperceptible, just a slight difference in position. But night after night, it continues, slowly accumulating, until entire constellations seem to arrive earlier than they once did. This quiet drift is one of the most beautiful clues that Earth does not simply spin in isolation, but moves through space in a layered and interconnected way. The key to understanding this lies in that small difference we uncovered earlier, the missing 4 minutes between a full rotation of Earth relative to the stars and the 24-hour day we live by. That difference is not random. It is the direct result of Earth's journey around the Sun, a journey that unfolds continuously, even as the planet spins beneath you. Imagine for a moment that you could pause the world and look down on Earth from far above. You would see it rotating steadily like a spinning sphere, but at the same time you would also see it moving along a vast path around the Sun. This path is so large that even in a single day, Earth travels millions of kilometers forward along its orbit. By the time one full rotation is complete, the planet is no longer in the same position it was before. Because of this, when Earth finishes a complete 360-degree spin relative to the distant stars, the Sun has shifted slightly in the sky. To bring the Sun back to the same position to create what we call a solar day, Earth must rotate just a little bit more. That extra rotation takes about 4 minutes, stretching the day from 23 hours and 56 minutes to the familiar 24 hours. This is why the stars and the Sun do not keep the same schedule. The stars follow the true rotation of Earth, while the Sun's position is influenced by Earth's orbit. Each day, the stars return to the same place a little earlier, while the Sun appears to stay aligned with our clocks. It is a quiet divergence, two different ways of measuring the same motion. Over time, this difference becomes impossible to ignore. After 1 week, the stars rise about 28 minutes earlier. After 1 month, nearly 2 hours. And after a full year, the cycle completes itself, bringing the stars back to their original positions in the night sky. This is why the constellations change with the seasons, why Orion dominates winter skies while Scorpius appears in summer. It is not the stars that are moving through the year. It is you, carried along by Earth's orbit, gradually changing your perspective of the cosmos. This slow shift also reveals something deeper about time itself. The 24-hour day we rely on is not a fundamental property of the universe. It is a convenient adjustment, a compromise between Earth's rotation and its orbit. In a sense, every clock you have ever used is already an approximation, a carefully averaged rhythm designed to match the Sun rather than the true spin of the planet. And yet, even this system is not perfectly stable, because Earth's orbit is not a perfect circle. It is slightly stretched, forming a shape known as an ellipse. This means that as Earth travels around the Sun, its speed changes. Sometimes it moves a little faster, sometimes a little slower. And when its speed changes, the amount of extra rotation needed each day also changes, ever so slightly altering the length of a solar day. This introduces a new layer to our mystery. Not only is Earth spinning and orbiting, but the speed of that orbit is constantly shifting. The rhythm of our days is not perfectly uniform. It stretches and compresses in subtle ways, too small to notice in daily life, but large enough to be measured with precision. If you were to track the exact moment when the sun reaches its highest point in the sky each day, what we call noon, you would find that it does not occur at exactly the same time every day. Sometimes it arrives a little early, sometimes a little late. Over the course of a year, this difference can grow to more than a quarter of an hour. This is not a flaw in your clock. It is a reflection of Earth's changing motion through space. So now the picture becomes more complex, but also more beautiful. Earth is not a perfectly steady machine ticking out identical days. It is a dynamic system, constantly adjusting, constantly shifting, tracing a path that is both predictable and ever-changing. The 4-minute difference we began with is only the first hint of this deeper complexity. And as we continue to follow this motion, another question begins to emerge. If Earth's speed changes as it moves around the sun, and if that change subtly reshapes the flow of our days, then what does that mean for the passage of time itself? Because in the next step of our journey, we will see that the sun itself seems to speed up and slow down in the sky, not because it is moving differently, but because Earth is. And in that shifting rhythm, we begin to uncover one of the most delicate and fascinating patterns in all of astronomy. A pattern that quietly reveals that even time does not flow as evenly as it seems. If Earth moved around the sun in a perfect circle at a perfectly constant speed, then the rhythm of our days would be far simpler. Each rotation would require almost exactly the same adjustment to bring the sun back into place, and time would feel more uniform, more predictable. But the universe rarely chooses perfect symmetry. Instead, Earth follows a path that is slightly stretched, a gentle oval rather than a circle, and within that shape lies another quiet mystery. As Earth travels along this elongated path, its distance from the sun changes throughout the year. At one point it comes slightly closer, and at another slightly farther away. The difference is not extreme, only a few million kilometers, but it is enough to alter the planet's speed. When Earth is closer to the sun, it moves a little faster. When it is farther away, it slows down. This constant shifting of speed is one of the fundamental patterns of motion in the cosmos, a balance between gravity and momentum playing out on a planetary scale. You can imagine it like a skater gliding across ice. When they pull their arms in, they spin faster. When they extend them outward, they slow down. In a similar way, as Earth moves closer to the sun, gravity pulls it into a slightly tighter, faster curve. As it drifts farther away, that pull weakens just enough to let it slow. This change is smooth and continuous, unfolding quietly over the course of the year. But here is where the mystery deepens. Because this changing speed does not just affect Earth's path through space. It also changes how we experience time on the surface of the planet. Each day, as Earth rotates, it must compensate for how far it has moved along its orbit. But if that orbital speed is not constant, then the amount of extra rotation needed each day is not constant either. Some days, Earth must turn a little more to catch up with the sun. Other days a little less. The difference is small, measured in seconds, but it accumulates. Over weeks and months, these tiny variations begin to shift the apparent motion of the sun in the sky. It may rise a little earlier than expected, or linger a little longer before setting. These changes are subtle, often unnoticed, but they are always there, quietly shaping the rhythm of light and shadow across the planet. This is why, if you pay close attention, the length of a solar day is not exactly the same every day. It stretches and contracts slightly, breathing in and out with the motion of Earth's orbit. The clock on your wall continues to mark steady seconds, but the sun follows a slightly different schedule, one dictated not by human design, but by celestial mechanics. There is something almost poetic about this. The idea that time, something we treat as rigid and exact, is actually influenced by the graceful curve of a planet's path around a star. That even the most reliable cycle in our lives, the day itself, is gently shaped by distance and motion. And yet, this is only part of the story, because there is another factor at play, something that adds a second layer of complexity to this shifting rhythm. Earth is not only moving along an elliptical orbit, it is also tilted, leaning slightly as it travels through space. This tilt changes how the sun appears to move across the sky, altering not just its timing, but its path. When these two effects combine, the changing speed of Earth's orbit and the tilt of its axis, they create a pattern that is both intricate and beautiful. A pattern that explains why the sun does not keep perfect time with our clocks, and why its motion in the sky is not as simple as it seems. If you could record the position of the sun at the same clock time every day for an entire year, you would not see a straight line. Instead, you would see a looping figure, a shape that curves and crosses itself, forming something like a stretched and twisted number 8. This shape is a direct imprint of Earth's motion, a visual trace of how speed and tilt combine to create the subtle irregularities in solar time. But before we fully uncover that pattern, it is worth pausing to reflect on what we have already discovered. The Earth does not move at a constant speed. Its orbit is not perfectly circular. Its days are not perfectly uniform, and the time we experience is already beginning to reveal itself as something more flexible, more dynamic than we might have imagined. So now the question grows deeper. If even the motion of the sun in our sky is shaped by these hidden variations, then how closely does our idea of time truly match reality? Because in the next step of our journey, we will explore the phenomenon that ties all of this together, a quiet mathematical correction that explains why clocks and sunlight never fully agree, and why the sun sometimes seems to fall behind or race ahead. There is a quiet moment you may have noticed without realizing it. A day when the sunset feels slightly late, as if the light is lingering just a little longer than expected. Or a morning when dawn arrives a few minutes earlier, slipping in before your sense of time is ready for it. These moments are easy to dismiss, easy to blame on habit or perception. But they are real, and they are part of a deeper pattern hidden within Earth's motion. Because the sun, as steady and predictable as it seems, does not keep perfect time. If you were to measure the exact moment each day when the sun reaches its highest point in the sky, what astronomers call true noon, you would find that it slowly drifts. Some days it arrives a little earlier than 12 o'clock. Other days a little later. Over the course of a year, this difference grows and shrinks, reaching as much as about 15 or 16 minutes away from our clocks. This phenomenon is known as the equation of time, though the name hides how subtle and beautiful it truly is. It is not a flaw or an error. It is the natural consequence of Earth's motion, the combined effect of its changing speed and its tilted axis. It is the reason why solar time, the time measured by the sun itself, never perfectly aligns with the uniform ticking of a clock. To understand this, imagine again that you are watching Earth from above, observing both its rotation and its orbit. Each day, the planet must rotate just enough to bring the sun back to the same position in the sky. But because Earth's orbital speed changes, as we explored earlier, the amount of extra rotation required is not always the same. When Earth is moving faster along its orbit, it has traveled a slightly greater distance by the time it completes one rotation, so it must turn a little more to catch up. When it is moving slower, it needs slightly less. At the same time, Earth's axis is tilted, leaning at an angle as it moves through space. This tilt changes the apparent path of the sun across the sky, causing it to move north and south over the course of the year. As a result, the sun does not travel along a perfectly straight path relative to our clocks. Its motion is slightly skewed, slightly uneven, adding another layer to the variation. When these two effects combine, the changing speed and the tilted orientation, they create a subtle but measurable mismatch between solar time and clock time. This is the equation of time, a quiet correction that reveals the difference between how we measure time and how the cosmos actually behaves. If you could take a photograph of the sun at the exact same clock time every day for a full year, always from the same location, you would capture something remarkable. Instead of forming a straight line in the sky, the sun's positions would trace a looping figure, a shape like a stretched and tilted number 8. This pattern is called the analemma, and it is one of the most elegant visual signatures of Earth's motion. Each loop of this figure tells a story. The vertical stretch reflects the tilt of Earth's axis, showing how the sun's height changes through the seasons. The horizontal spread reflects the equation of time, showing how the sun runs ahead of or behind our clocks. Together, they form a map of imperfection, a reminder that even the most familiar cycles are shaped by hidden complexities. There is something deeply calming about this realization. The fact that the sun does not keep perfect time, that its motion drifts and shifts, yet remains completely predictable over long periods. It is a balance between variation and order, between change and stability. The system is not rigid, but it is reliable. And this has real consequences in everyday life, even if we rarely notice them. It explains why the earliest sunset of the year does not occur on the shortest day, and why the latest sunrise does not fall exactly on the longest night. It is why sundials, ancient instruments that measure time directly from the sun, do not always match modern clocks. The sun follows the laws of physics, not the conventions of human timekeeping. This brings us back to the deeper question that has been quietly forming throughout this journey. If the sun itself does not align perfectly with our clocks, if the length of a day subtly changes and the moment of noon drifts across the year, then what does it really mean to measure time? Because what we call time is not something absolute. It is something constructed, something adjusted, something carefully aligned to match a world that is constantly in motion. Our clocks tick evenly, but the universe does not. It flows, it shifts, it curves along paths shaped by gravity and motion. And yet, within that flowing complexity, there is harmony. The variations repeat in cycles. The analemma returns year after year. The drift of the sun is predictable, even if it is not perfectly uniform. It is a system that balances change with consistency, allowing life to exist within it. So as we move forward, the mystery deepens. We have seen that Earth's motion reshapes the length of a day, alters the timing of the sun, and reveals that time itself is not as fixed as it appears. But this is only the beginning, because if time can shift and stretch simply from the motion of a planet, then what happens when motion becomes more extreme? When speed increases, when gravity grows stronger, when the very fabric of space is involved. In the next part of our journey, we will leave the familiar rhythms of Earth behind and step into a stranger idea. The possibility that time itself is not universal, not constant, and not shared equally by everything in the universe. And once we see that, the meaning of a single second may never feel the same again. If you could step outside the flow of days and watch an entire year unfold all at once, you would begin to see a pattern emerge, something gentle and repetitive, yet never perfectly uniform. The sun would not trace the same path in the sky each day. Instead, it would wander slightly, drifting ahead, then falling behind, rising higher, then lower, as if following a rhythm more complex than a simple circle. Now imagine capturing that motion. Every day at the exact same clock time, you take a single image of the sun. You return to the same place, stand in the same position, and repeat this process for an entire year. When you finally place those images together, you would not see a straight line. You would see a looping figure, a graceful shape that curves and crosses itself, like a stretched number 8 floating in the sky. This is the analemma. It is not just a pattern. It is a signature, a direct imprint of how Earth moves, revealing both the tilt of its axis and the changing speed of its orbit in a single elegant form. Every curve in that shape tells a story about motion, about imbalance, about the quiet ways the universe refuses to be perfectly regular. The vertical stretch of the analemma shows the changing height of the sun across the seasons. When the curve rises, it reflects the time of year when your hemisphere is tilted toward the sun, when sunlight arrives more directly, and days feel longer and warmer. When it dips downward, it marks the opposite, when your part of Earth leans away, and the sun traces a lower path across the sky. But the horizontal spread of the shape is even more subtle. It reveals how the sun drifts ahead of or behind our clocks. On some days, the sun arrives early, reaching its highest point before noon by the clock. On others, it lags behind, crossing the sky later than expected. This sideways motion is the visible trace of the equation of time, the combined effect of Earth's elliptical orbit and its tilted axis. Together, these two dimensions form a complete picture of imperfection. A system that is not symmetrical, not constant, yet entirely predictable. It repeats year after year, not because it is simple, but because it follows deeper laws, laws that allow variation without chaos. There is something quietly profound about this. The fact that time itself, something we often think of as rigid and exact, is actually shaped by curves, angles, and changing speeds. The analemma reminds us that the passage of time is not a straight line. It bends, it shifts, it carries the imprint of motion within it. And yet, despite all this variation, our lives feel stable. Days come and go. Clocks tick steadily. We wake, we sleep, we measure our lives in hours and minutes that seem perfectly uniform. This is because we have chosen to smooth out the irregularities. Our timekeeping systems are built on averages, on carefully adjusted standards that hide the small fluctuations of Earth's motion. In doing so, we create the illusion of perfect time, a system where every second is equal, every day is the same length, and every year follows a neat, predictable structure. But beneath that surface, the real motion continues, quietly deviating, quietly reminding us that the universe does not operate on human definitions. This realization leads us gently into the next layer of our journey. Because so far, we have been exploring how Earth's motion reshapes time from our perspective on the surface. We have seen how rotation, orbit, tilt, and changing speed all combine to create subtle variations in the flow of days. But what if these variations are only the beginning? What if time itself is not just influenced by motion, but actually created by it? What if the steady ticking of a clock is not a universal truth, but a local experience, something that depends on where you are, how fast you are moving, and even how strong gravity is around you? These questions may feel abstract, almost philosophical, but they are not. They are grounded in physics, in experiments, in measurements so precise that they reveal something deeply unsettling and strangely beautiful at the same time. Because as we move into the next part of this journey, we will begin to see that time is not shared equally across the universe. That there is no single moment that exists everywhere at once. And that the seconds you experience right now may not match the seconds experienced somewhere else. The motion of Earth has already shown us that time can drift. What comes next will show us that time can bend. There is a quiet assumption we all carry without ever questioning it. The idea that this moment right now is happening everywhere at once. That somewhere, far across the world or deep in space, there is a shared now connecting everything together. It feels natural, almost obvious, as if time flows like a river moving in one direction for everyone, equally and without exception. But this feeling is not true. The moment you are experiencing right now does not exist in the same way everywhere else. To begin understanding this, we have to gently let go of something very familiar. The idea that time is absolute, that it ticks the same way for every observer, no matter where they are or how they move. For most of human history, this idea felt perfectly reasonable. Clocks could be synchronized. Days could be divided into equal parts. Time seemed like a universal background, something steady and unchanging behind all events. But as our understanding deepened, something unexpected emerged. Time is not a fixed stage where events unfold. It is part of the system itself, woven together with motion, with space, with gravity. It does not exist independently. It depends. Imagine two observers. One is resting quietly on Earth, carried along by the planet's motion. The other is traveling at an enormous speed, moving far faster than anything we experience in everyday life. From their own perspectives, each one feels normal. Their heartbeats are steady. Their thoughts flow naturally. Their clocks tick as expected. But when they compare their clocks, something strange happens. They do not agree. The one who has been moving faster will have experienced slightly less time. Their clock will show fewer seconds have passed. Not because it malfunctioned, not because it was inaccurate, but because time itself moved differently for them. This effect is incredibly small at the speeds we encounter in daily life, so small that we never notice it. But it has been measured with extraordinary precision. When clocks are carried on fast-moving aircraft and compared to identical clocks left on the ground, they come back slightly out of sync. The difference is tiny, but it is exactly what physics predicts. This is the beginning of a profound shift in understanding. Time is not universal. It is relative. It depends on motion. And motion, as we have already seen, is everywhere. The Earth is spinning. It is orbiting the Sun. The Sun is moving through the galaxy. Everything is in motion, layered upon motion, which means that time itself is not the same everywhere within this moving system. It varies subtly but continuously, depending on how each part of the system is moving. But motion is only part of the story. There is another influence, one that is even more surprising. Gravity. If you were to place one clock on the surface of Earth and another far out in space, far from the planet's gravitational pull, you would again find a difference. The clock closer to Earth, deeper within its gravity, would run slightly slower. The one farther away would run faster. This is not because gravity is interfering with the clock mechanically. It is because gravity changes the flow of time itself. The stronger the gravitational field, the slower time passes. So now the picture becomes even more complex, but also more beautiful. Time is shaped by motion and by gravity. It stretches and compresses depending on where you are and how you move. There is no single universal clock governing the entire universe. Instead, every location has its own time. Every path through space carries its own rhythm. This leads us to a quiet but powerful realization. The idea of a shared present moment, a single now that exists everywhere, is not something the universe provides. It is something we create in our minds, a convenient simplification that helps us navigate daily life. In reality, what is happening now for you may not be happening at the same moment for something far away, especially if it is moving differently or experiencing a different gravitational environment. The universe does not synchronize itself to our expectations. It allows each part to experience time in its own way. And yet, despite this complexity, we live as if time is uniform. Our clocks agree. Our schedules align. We share moments with others as if they are happening simultaneously. This works because the differences are so small in our everyday environment that they become invisible. But they are there, quiet, constant, and real. So now we return to our central mystery, but it has changed. We began by asking why Earth moves without us feeling it. We followed that motion into the structure of days, into the shifting rhythm of the sun, into the subtle imperfections of timekeeping. And now we arrive at something deeper. If time itself is not fixed, if it depends on motion and gravity, then what we experience as a steady flow may only be a local illusion, shaped by the conditions around us. Which leads to an even more unsettling question. If time is not universal, then what exactly are we measuring when we measure a second? And in the next part of this journey, we will explore that question further, moving from the quiet drift of clocks into the deeper structure of reality itself, where time is no longer a background, but a dynamic and flexible part of the universe. If time can slow down or speed up depending on motion, then something very strange begins to unfold. It means that time is not something that simply exists on its own. It is not a universal background ticking away independently of everything else. Instead, it is tied directly to movement, to how fast something travels through space. To understand this more deeply, imagine a simple thought experiment. Picture two identical clocks, perfectly synchronized. One remains on Earth, resting quietly on the surface, moving only with the planet's natural motions. The other is placed aboard a spacecraft that accelerates to an enormous speed, far beyond anything we can experience in everyday life. From the perspective of the person on Earth, the spacecraft is racing through space. From the perspective of the traveler, however, everything feels normal. Inside the spacecraft, nothing seems different. The clock ticks as usual. The traveler breathes, thinks, and experiences time exactly as they always have. There is no sensation of time slowing down. But when the spacecraft returns and the two clocks are compared, something unexpected appears. The traveling clock shows less time has passed. The journey, from the traveler's perspective, was shorter in time than it was for the person who stayed behind. This is not an illusion. It is not a trick of measurement. It is a real effect. Time itself has passed differently for the two observers. The faster something moves, the more pronounced this effect becomes. At everyday speeds, it is so small that it goes unnoticed. But as speed increases, especially approaching the speed of light, the difference becomes dramatic. Time for the moving object slows relative to the stationary observer. Not metaphorically, but physically. This leads to a profound realization. Motion does not just carry you through space. It changes how you move through time. You can think of it as a kind of balance. There is a fundamental limit to how fast anything can move through the combined structure of space and time. When more of that motion is directed through space, less is available for moving through time. So as speed increases, the passage of time slows. This is not something we feel because everything around us shares our motion. Just as you do not feel Earth spinning because everything moves together, you do not feel time slowing because your entire frame of reference is affected equally. Your thoughts, your heartbeat, even the processes within your cells all adjust together. And yet, when compared to something outside that frame, the difference becomes visible. This idea may feel abstract, but it has very real consequences. It is not limited to distant spacecraft or theoretical scenarios. It is already part of the technology we use every day. Systems that rely on precise timing must account for these differences. Without doing so, even small discrepancies would grow into significant errors. So now the mystery deepens again. We have moved beyond the idea that Earth's motion shapes time in subtle ways. We have entered a realm where motion itself can alter the rate at which time flows. But there is still another layer to uncover. Because motion is not the only thing that affects time. Gravity, the force that shapes the structure of the universe, also plays a role. And its influence is just as profound. Imagine again two identical clocks. This time, instead of moving one at high speed, you place one deep within a strong gravitational field, perhaps near a massive object, while the other remains far away where gravity is weaker. When you compare them, you find something just as surprising as before. The clock closer to the massive object, deeper in the gravitational field, has experienced less time. It has ticked more slowly. Gravity, in a sense, stretches time. The stronger the gravity, the slower time flows. This means that time is not only relative to motion, but also to position within a gravitational field. Where you are in the universe changes how time passes for you. Now consider how this connects back to Earth. Even here, where gravity feels constant and unchanging, there are tiny differences. A clock placed at a higher altitude, slightly farther from Earth's center, will run a little faster than one at sea level. The difference is incredibly small but measurable. So even on our own planet, time is not perfectly uniform. It varies, quietly, constantly. This brings us to a deeper understanding of what time really is. It is not a universal flow that everything follows. It is a local experience, shaped by motion and gravity, changing from place to place and from moment to moment. And yet, despite all of this complexity, our daily lives remain stable. We wake up, we go about our routines, and we measure time as if it were perfectly consistent. This works because the variations are small within our environment. But beyond that familiar scale, the differences become impossible to ignore. So now we return once again to the central question, but it has evolved even further. If time can slow down with motion and stretch under gravity, then what we call a second is not a universal unit. It is something defined within a specific context, under specific conditions. And that raises a quiet, almost philosophical thought. If time changes depending on how you move and where you are, then is time something that exists independently at all? Or is it something that emerges from the motion of the universe itself? In the next part of our journey, we will explore this idea more deeply. We will move beyond clocks and measurements and begin to ask whether time is a fundamental feature of reality or simply a way of describing change. And the answer may feel less like a definition and more like a shift in how we see existence itself. As we follow this idea deeper, something subtle begins to shift. At first, we thought of time as something that flows, like a river carrying everything forward. Then we discovered it depends on motion and gravity, stretching and compressing depending on where you are and how you move. But now, an even quieter realization begins to emerge. What if time is not something that flows at all? What if time is simply a way of describing change? To explore this, imagine a universe where nothing moves. No planets orbit. No stars burn. No atoms vibrate. No light travels. Everything is completely still, frozen in a single unchanging state. In such a universe, what would time mean? There would be no before and after because nothing would ever change. No events would occur. No processes would unfold. Without change, there would be nothing to measure, nothing to compare, nothing to mark the passage from one moment to the next. In that sense, time would not just slow down. It would disappear. This idea may feel abstract, but it is deeply rooted in how physics understands the world. Time is not something we can observe directly. We never see time itself. What we observe are changes. The movement of a clock's hands, the oscillation of atoms, the rotation of Earth, the shifting of light and shadow. Every measurement of time is actually a measurement of change. A second is defined by the vibration of atoms. A day is defined by the rotation of Earth. A year is defined by its orbit around the sun. Remove the motion, remove the change, and these definitions lose their meaning. So in a very real sense, time is not a thing that exists independently. It is a relationship between states, a way of describing how one configuration of the universe becomes another. This perspective transforms how we think about everything we have explored so far. The shifting length of a day, the drifting position of the sun, the slowing of time with motion and gravity, all of these are not distortions of time itself. They are reflections of how change unfolds under different conditions. Time does not bend on its own. Change bends, and we experience that bending as time. This leads to another quiet insight. If time is tied to change, then every system carries its own version of time. A fast-moving object experiences change differently than a stationary one. A region under strong gravity experiences change differently than one in empty space. Each frame of reference has its own unfolding of events, its own sequence of changes. This is why there is no single universal clock. There is no master timeline that everything follows. Instead, there are countless local timelines, each defined by the motion and conditions of its environment. And yet, within our daily lives, this complexity remains hidden. The changes around us are consistent enough that time feels uniform. The Earth rotates steadily. Our bodies follow regular rhythms. Our clocks are synchronized. All of these factors combine to create the illusion of a single, shared flow of time. But beneath that illusion, the deeper truth remains. Time is not something we move through. It is something we create through change. And this brings us back once again to Earth. Because everything we experience, every second, every day, every year, is built upon the motion of this planet. Its rotation defines our days. Its orbit defines our years. Its tilt shapes our seasons. Its movement through space connects us to the larger structure of the cosmos. Without that motion, our sense of time would dissolve. So when you think about a single moment, this very second, it is not just a point on a timeline. It is the result of countless processes unfolding together. The turning of Earth, the motion of your body, the activity of your thoughts, the interactions of particles at scales too small to see. All of these changes combine to create what you experience as now. And yet, as we have already seen, This now is not shared universally. It is local. It belongs to your frame of reference, shaped by your motion and your position in the universe, which means that time is not a single thread running through reality. It is a tapestry of countless threads, each one woven from change. So now the question evolves once more. If time is not fundamental, if it emerges from change, then what happens when we look even deeper? What happens at the smallest scales, where particles behave in ways that seem to defy our usual understanding of motion and sequence? Does time still exist there in the same way? Or does it begin to dissolve into something even more unfamiliar? In the next part of our journey, we will move into that strange territory, where the classical idea of smooth, continuous time begins to break down, and where the universe reveals that even the concept of a flowing moment may not apply in the way we expect. And as we explore that, we will come closer to answering the question that has been quietly guiding us all along. Not just how Earth moves, but how movement itself gives rise to the experience of time. As we continue moving deeper into this quiet mystery, something even more unusual begins to appear. So far, time has revealed itself as flexible, shaped by motion and gravity, emerging from change rather than existing on its own. But all of this still assumes something familiar, that time flows smoothly, like a continuous stream where one moment follows another in an unbroken sequence. Yet when we look closer, when we move down to the smallest scales of reality, even that assumption begins to fade. At the level of everyday experience, everything seems continuous. You breathe in, then out. Your thoughts move from one to the next. The world unfolds in a steady progression. But at the scale of atoms and particles, this smoothness disappears. Instead of continuous motion, there are discrete events, tiny interactions that occur in jumps rather than flows. Particles do not trace neat paths through space like planets orbiting a star. They exist in states, and then they change, often in ways that can only be described in terms of probability rather than certainty. In this strange domain, time does not behave like a steady backdrop. It becomes something harder to define. Between one interaction and the next, there is no clear sense of a ticking clock. Instead, there are transitions, moments where something changes, and in between, the concept of time becomes less meaningful. It is as if time only appears when something happens, and fades away when nothing does. This idea challenges one of the deepest intuitions we have. We tend to think that time is always there, even if nothing is happening. That there is an invisible clock continuing to tick in the background of the universe. But at these fundamental levels, that assumption may not hold. Time may not exist as a continuous entity, but rather as something that emerges from interactions, from events themselves. Imagine again that frozen universe we considered earlier, where nothing moves. At large scales, we already saw that time would lose its meaning. But at the smallest scales, the situation is even more striking. Without interactions, without exchanges of energy or information, there would be no sequence of events to define any passage at all. Time would not just be unmeasurable, it would be undefined. This leads to a remarkable possibility. Time may not be a fundamental ingredient of reality. Instead, It may arise from deeper processes, from the relationships between particles, from the way systems evolve from one state to another. In this view, time is not something the universe contains. It is something the universe generates. And yet, despite this underlying complexity, the world we experience remains smooth and continuous. This is because, at larger scales, countless tiny interactions combine, blending together into patterns that appear steady and predictable. Just as individual grains of sand form a continuous beach, discrete events at the microscopic level create the illusion of flowing time at the macroscopic level. This blending is what allows us to experience time as a seamless progression. It is why we can speak of seconds and minutes, why clocks can measure intervals, why the rotation of Earth can define a day. All of these are large-scale patterns emerging from countless smaller processes. But beneath that smooth surface, the true nature of time may be far more fragmented, more event-based, more dependent on change than we ever realized. Now, as we bring this understanding back to Earth, something becomes clear. Every moment you experience is not a single continuous thread, but the result of countless tiny changes happening together. The motion of your body, the activity of your brain, the interactions of particles within you and around you, all of these combine to create the sense of a flowing present. And all of it is tied to motion, the Earth turning beneath you, the planet moving around the sun, the solar system drifting through the galaxy. Each layer of motion contributes to the unfolding of events, to the sequence of changes that you experience as time. So when we ask what time really is, we arrive at a quieter answer than we might expect. Time is not a universal river carrying everything forward. It is the pattern of change within a moving universe. It is the way motion reveals itself through sequence, through difference, through transformation. And this brings us back, once again, to the central thread of our journey. Earth moves, constantly, silently, carrying you through space in ways you cannot feel. And from that motion, from those layered movements, emerges the structure of your experience, the rhythm of your days, and even the flow of time itself. But there is still one more layer to uncover. Because everything we have explored so far, motion, time, change, is happening within a larger framework. A framework that includes not just Earth, not just the solar system, but the entire galaxy and beyond. And when we follow Earth's motion into that larger scale, we begin to see something even more humbling. That our planet is not just spinning and orbiting. It is traveling, drifting through a vast cosmic structure, carried along paths that stretch far beyond anything we can see. So as we move into the next segment, we will leave behind the question of what time is, and begin to ask something equally profound. If Earth is always moving, then where is it actually going? By now, something subtle but profound has begun to settle in. The idea that time is not universal, not fixed, not something that exists independently of everything else. Instead, it depends on motion, on gravity, on change itself. But if we follow this realization all the way to its edge, we arrive at a conclusion that feels almost impossible at first. There is no single clock governing the universe. No master timeline that everything follows. No universal now shared by all things. To understand this, Imagine the universe not as a single synchronized system, but as a vast collection of moving parts, each following its own path, each experiencing its own flow of change. Every star, every planet, every particle carries its own version of time, shaped by its motion and its environment. These timelines do not perfectly align. They overlap, they diverge, they stretch and compress relative to one another. This means that the idea of a universal present moment, a single instant that exists everywhere at once, is something that does not truly exist in nature. It is something we construct, something that emerges from our limited perspective as observers moving together on the same planet. Within our shared frame of reference, time feels unified. But beyond that, the unity dissolves. Consider two distant events happening far apart in the universe. From one perspective, they may appear simultaneous. From another, one may occur before the other. There is no absolute answer to which one is truly first. The order depends on the observer, on how they are moving, on where they are located. This is not a limitation of our measurement. It is a fundamental property of reality. So time, as we experience it, is local. It belongs to each observer, each system, each path through space. Your experience of time is tied to your motion, your position, your environment. It is not identical to the experience of something far away, moving differently, existing under different conditions. And yet, despite this fragmentation, the universe does not feel chaotic. There is still structure, still order, still a sense of continuity. This is because the laws governing motion and change are consistent. They do not enforce a single timeline, but they do ensure that all timelines relate to each other in predictable ways. It is like a vast symphony without a single conductor. Each instrument plays its own part, following its own rhythm, yet all are connected through underlying patterns. The result is not disorder, but a deeper, more complex harmony. Now, bring this understanding back to Earth. The planet beneath you is part of this system. It is not isolated. It is moving through a web of gravitational influences, interacting with the sun, the moon, the galaxy, and beyond. Every layer of this motion contributes to the way time unfolds here, shaping the rhythm of days, the flow of seasons, the pace of life itself. But Earth's timeline is only one among many. Somewhere else, time flows differently. Not dramatically in most cases, but enough to remind us that our experience is not universal. It is specific, local, tied to this particular path through space. This realization can feel unsettling at first. The loss of a shared universal now challenges something very intuitive in how we see the world. But it also opens a new way of understanding existence. Instead of a single timeline, there is a network of timelines. Instead of one flow of time, there are many, each valid within its own context. And within this network, your life unfolds. Every moment you experience is part of your path through this structure. A path defined by the motion of Earth, by the orbit around the sun, by the journey through the galaxy. Your time is not separate from these motions. It is created by them. So when you think about a single day, it is not just a rotation of the planet. It is a segment of a much larger trajectory, a small arc in a vast, multidimensional journey. The seconds you count are not universal units, but local markers tied to the specific conditions of your environment. And this brings us gently to the threshold of the next part of our journey. Because now that we understand time as local, as relative, as emerging from motion and change, we can begin to ask a different kind of question. If time is not universal, then what about the structures we build around it? The idea of noon, of days, of calendars, of shared schedules across the world. How do these human systems align with a planet that is constantly moving, constantly shifting, never perfectly repeating its motion? Because as we move forward, we will return to Earth once more, but with a new perspective. Not just as a spinning planet, but as a world where even something as simple as midday is not the same everywhere. Where human time and cosmic motion quietly diverge. And in that divergence, we will see how deeply our lives are shaped by a planet that never stands still. There is a moment each day that feels perfectly defined. A point we call noon, when the clock strikes 12 and we imagine the sun standing at its highest place in the sky. It feels precise, fixed, shared across entire regions of the world. But like everything we have explored so far, this too is an illusion, a quiet simplification placed over a far more complex reality. Because true noon, the actual moment when the sun reaches its highest point above your location, is not the same everywhere. It does not occur at exactly 12 o'clock on your clock. In fact, for most places on Earth, it almost never does. To understand why, we return to something simple yet profound. The Earth is rotating, and as it turns, different longitudes face the sun at slightly different times. If you move just a small distance east or west, the moment when the sun reaches its peak shifts by a few minutes. Across the entire planet, this creates a continuous gradient of solar time, where every location has its own slightly different noon. Before modern timekeeping, this was how people lived. Each town set its clocks based on the sun. Noon was simply when the sun stood highest in the sky at that location. It was natural, intuitive, and directly connected to the motion of the Earth. But as human society grew more connected, this system became impractical. With the rise of railways and communication networks, time needed to be standardized. Trains could not run safely if every town operated on a slightly different schedule. Messages could not be coordinated if noon meant something different in every place. So humanity made a choice. Instead of following the sun precisely, we divided the world into time zones. Each zone covers a wide band of longitude and shares a single standard time. Within that zone, everyone agrees that noon happens at the same moment on the clock. But the sun does not follow these boundaries. In reality, within any given time zone, there is a spread of solar noon times. At the eastern edge, the sun reaches its highest point earlier. At the western edge, it arrives later. The difference can be as much as an hour or more, depending on the size of the region. This means that when your clock reads 12 o'clock, the sun may already have passed its highest point, or it may not have reached it yet. The time you call noon is not the true peak of the sun, but an agreed-upon average, a convenient approximation. And this is only part of the story. Because even at a single location, true noon does not occur at the same clock time every day. As we explored earlier, The equation of time causes the sun to drift ahead or behind our clocks by up to about 16 minutes over the course of a year. This means that even if you stayed in one place watching carefully each day, you would see noon slowly shift back and forth. So now we see that noon is shaped by multiple layers of motion. The rotation of Earth creates local differences. Time zones smooth those differences into a shared system, and the changing speed and tilt of Earth's orbit introduce a seasonal drift on top of it all. What feels like a fixed moment is actually the result of overlapping adjustments, a balance between natural motion and human design. There is something quietly fascinating about this. The idea that one of the most familiar points in our daily lives is not anchored in a single absolute event, but in a compromise between the movement of the planet and the needs of society. It reminds us that our experience of time is always a translation, a way of mapping the continuous, flowing motion of the Earth onto a system we can use, understand, and share. And yet, beneath that system, the real motion continues unchanged. The sun still crosses each meridian once per day. The Earth still turns at its own pace. The true rhythm of solar time remains, even if we choose not to follow it exactly. This brings us back to the deeper theme that has been guiding this journey. Earth moves, constantly, quietly, shaping everything we experience. Even something as simple as noon is not fixed, but emerges from that motion. And as we continue, we begin to see that our entire system of timekeeping is built on similar adjustments. Days are averaged, years are corrected, small discrepancies are constantly smoothed out to keep our calendars aligned with a planet that never moves in perfect repetition. Which leads us to the next question. If even a single day requires adjustment to stay aligned with Earth's motion, then what about the year? How do we keep track of a planet whose orbit does not fit neatly into whole numbers? Because the answer to that question reveals another quiet correction, one that appears only occasionally, but carries the same message as everything we have seen so far. That time, as we measure it, is not fixed. It is maintained. Every few years, something unusual happens, though most people barely notice it. A single extra day appears in the calendar. February gains a 29th day, and the year becomes just a little longer than usual. It feels like a small adjustment, almost arbitrary, something we accept without much thought. But that extra day is not random. It is a quiet correction, one of the most elegant ways humanity has tried to stay aligned with a planet that never moves in perfect numbers. Because the Earth does not take exactly 365 days to orbit the Sun. Instead, the journey takes slightly longer, about 365 days, 5 hours, 48 minutes, and 45 seconds. That small fraction of a day may seem insignificant, but it accumulates. Each year, our calendar would drift by nearly 6 hours if we did nothing to correct it. After 4 years, that drift would become almost a full day. And so we add one. This is the leap year, a simple but profound adjustment that keeps our human system of time from slowly slipping away from the natural rhythm of Earth's motion. Without it, the seasons would begin to shift relative to the calendar. Spring would arrive earlier each year, summer would drift backward, and over centuries, the alignment between dates and seasons would completely unravel. But even this correction is not perfectly simple. If we added a full day every 4 years without exception, we would slightly overcorrect. The true length of the year is not exactly 365.25 days, but a little less. That difference, just a few minutes per year, builds up over time. And so, another layer of adjustment is added. Some years that would normally be leap years are skipped, following a pattern that keeps the calendar even more closely aligned with Earth's orbit. What emerges is a system that is both precise and imperfect at the same time. A structure built not on exact repetition, but on continuous correction. Each leap day is a reminder that time, as we measure it, is not a fixed quantity. It is something we maintain, something we gently adjust to keep in harmony with the motion of the planet. There is something quietly beautiful about this. The idea that our calendar is not a rigid structure, but a living one, adapting to the subtle irregularities of Earth's path around the Sun. That every few years we pause and realign ourselves, bringing our system back into step with the cosmos. And this connects directly to everything we have explored so far. The drifting of solar noon, the changing length of days, the shifting motion of Earth along its orbit. All of these variations point to the same truth. The universe does not operate on perfect, repeating intervals. It moves in patterns that are consistent but not exact. Our response has been to create systems that smooth out those variations, that translate the complexity of motion into something we can use. Clocks average the length of a day. Time zones standardize local differences. Leap years correct the mismatch between days and years. But beneath all of these systems, the real motion continues, unchanged and unconcerned with our adjustments. The Earth follows its path. It does not pause for leap days. It does not align itself with our calendars. It moves according to gravity, according to geometry, according to the same laws that govern every object in the universe. And yet, through these small corrections, we stay connected to that motion. We keep our lives aligned with the cycle of seasons, with the return of sunlight, with the slow turning of the year. It is a quiet partnership between human order and cosmic reality. And it reveals something deeper about time itself. That precision is not about perfection. It is about alignment, about staying close enough to the truth of motion that our measurements remain meaningful. So when that extra day appears, it is more than just a calendar event. It is a moment of synchronization. A subtle acknowledgement that the Earth's journey does not fit neatly into our definitions, and that we must occasionally adjust to keep pace. Now, as we step back from this, another layer of the mystery begins to emerge. Because while the orbit of Earth defines the length of a year, and its rotation defines the length of a day, there is another factor that shapes our experience of time in a far more visible way. A slight tilt, a gentle lean of the planet as it moves through space. This tilt changes how sunlight reaches the surface, creates the seasons. It determines when days are long or short, when warmth rises or fades. It is one of the most influential features of Earth's motion, and yet it is just a small angle barely noticeable on a cosmic scale. And in the next part of our journey, we will explore how that tiny tilt transforms the entire character of life on Earth, shaping not just time, but climate, cycles, and the very rhythm of the world you experience every day. There is a detail about Earth that seems almost insignificant at first, a slight lean, a gentle tilt of just over 23 degrees. If you were to look at the planet from far away, it would not appear perfectly upright as it moves around the sun. Instead, it would seem to be tilted like a spinning top that never quite stands straight. And yet, this small angle quietly controls one of the most powerful patterns in your life: the seasons. Without this tilt, the Earth would still spin. It would still orbit, the sun days and nights would continue, and years would pass. But something essential would be missing: the variation, the change, the shifting rhythm of light and temperature that defines the world as you know it. If Earth were perfectly upright, every place on the planet would receive nearly the same pattern of sunlight throughout the year. The equator would remain warm and stable. The poles would stay cold and dim. There would be no gradual transition from winter to summer, no long evenings of warm light, no quiet shortening of days as the year turns. The world would become more static, more uniform, less dynamic. But because Earth is tilted, everything changes. As the planet orbits the sun, this tilt remains pointed in the same direction in space. That means different parts of Earth lean toward the sun at different times of the year. When your hemisphere tilts toward the sun, sunlight strikes more directly. The days grow longer. The warmth increases. This is summer. 6 months later, your hemisphere tilts away. Sunlight arrives at a shallower angle. Days shorten. Temperatures fall. This is winter. It is not the distance from the sun that creates the seasons. It is the angle. This is one of the most common misunderstandings, and yet one of the most important clarifications. Earth is actually slightly closer to the sun during the northern hemisphere's winter than during its summer. But because the angle of sunlight is less direct, the energy spreads over a larger area, reducing its intensity. The tilt shapes how that energy is distributed across the surface, and that distribution defines the seasons. Now imagine this tilt as part of the larger motion we have been following. Earth is not just orbiting. It is leaning as it moves, presenting different faces to the sun over time. This creates a cycle of changing light, a slow oscillation that defines the rhythm of the year. At certain points in this cycle, something special happens. When the tilt is balanced just right, both hemispheres receive nearly equal sunlight. Day and night become almost the same length everywhere. These moments are known as equinoxes, points of balance in the yearly motion. At other times, the tilt reaches its extremes, marking the longest and shortest days of the year, the solstices. These transitions are not abrupt. They unfold gradually, almost imperceptibly from one day to the next. But over weeks and months, the changes become clear. The sun climbs higher in the sky. Shadows shorten or lengthen. The air warms or cools. Life responds. Plants grow, bloom, and rest. Animals migrate, adapt, and prepare. Entire ecosystems shift in response to the changing distribution of sunlight. All of this, from the smallest leaf to the largest weather system, is guided by that single angle. And yet, even this tilt is not perfectly constant. Over very long periods, it slowly changes. It wobbles, influenced by the gravitational pull of the moon and other bodies in the solar system. The angle increases and decreases slightly over thousands of years, altering the intensity of seasons. When the tilt is greater, seasons become more extreme. Summers grow hotter, winters colder. When it is smaller, the differences soften. These slow variations are part of a larger pattern that has shaped Earth's climate over vast stretches of time. Ice ages have come and gone, influenced in part by these subtle shifts in tilt and orbit. The planet's environment is not fixed. It evolves, responding to changes in how sunlight reaches its surface. So once again, we see the same theme emerging. Nothing about Earth's motion is perfectly static. The rotation varies. The orbit shifts. The tilt changes. Each layer introduces variation, and together they create the complex, dynamic system we experience as time and climate. And yet, within all of this motion, there is stability. The patterns repeat. The seasons return. The cycles continue. Life adapts to these rhythms, finding balance within change. This brings us back to the quiet thread that has been guiding us from the beginning. Earth moves, not just in one way but in many. It spins, it orbits, it tilts, it drifts. And from these motions emerge the structures that define your experience. The length of your days, the flow of your time, the changing of your world. But even this is not the end of the journey, because all of these motions, rotation, orbit, tilt, are only part of a much larger movement. Earth is not just circling the sun. The sun itself is moving. The entire solar system is traveling through the galaxy, carried along paths that stretch far beyond anything we can see from the surface of our planet. So as we move into the next segment, we will step back even further, beyond the seasons, beyond the orbit, beyond the familiar structure of the solar system, and we will ask one final, humbling question. If Earth is always moving, then where, in the vastness of the universe, is it actually going? By now, the motion of Earth has become something deeper than a simple spin or orbit. It is layered, continuous, and quietly shaping everything you experience. But even these layers, rotation, orbit, tilt, are only the beginning, because Earth is not just moving around the sun. The sun itself is moving, carrying the entire solar system along a much larger path through the galaxy. Right now, as you rest without feeling the slightest movement, you are being carried through space at a speed that is almost impossible to imagine. The Earth is orbiting the sun, but the sun is not standing still. It is traveling around the center of the Milky Way, pulled by the gravity of billions of stars, following a vast circular path that takes hundreds of millions of years to complete. This motion is smooth and continuous, like a great cosmic current. The sun, along with all its planets, drifts through the galaxy at a speed of hundreds of kilometers every second. That means that in just a single minute, you have already traveled farther through the galaxy than any vehicle humanity has ever built could achieve in days. And yet, just like the rotation of Earth, you feel nothing, because everything around you is part of the same motion. The air, the ground, the oceans, even the sunlight that reaches you, all share this journey. There is no resistance, no sudden change, no reference point to reveal the movement. It is a perfect example of what we have seen before. Motion is invisible when it is shared. But if you could step outside this system, if you could watch the solar system from afar, you would see something extraordinary. The sun would not be moving in a simple circle. Instead, it would trace a kind of spiral path through space. As it orbits the center of the galaxy, the planets orbit the sun, creating a layered motion that looks like a twisting ribbon, a continuous wave flowing through the dark. Earth's path, then, is not a closed loop. It never returns to the same place in space. Each year, as it completes one orbit around the sun, the entire system has moved forward. The path is always new, always extending into regions of the galaxy it has never visited before. This means that no moment in your life is ever repeated in space. Even if the calendar returns to the same date, even if the seasons cycle back, you are not where you were before. You are somewhere entirely new, carried along by the motion of the galaxy. And the motion does not stop there. The Milky Way itself is moving. It is part of a larger structure, a collection of galaxies drifting together through space, influenced by gravitational forces on an even grander scale. This means that the path you are following is not just a spiral around the galaxy, but part of an even larger flow, one that extends across millions of light years. So when we ask where Earth is going, the answer becomes more complex than a single destination. It is not heading toward a fixed point in the way we might imagine. Instead, it is part of a network of motions, each layer influencing the next, each path nested within a larger one. You are moving in circles and in spirals and in long drifting arcs all at once. And yet, your experience remains calm and steady. This is one of the most remarkable aspects of the universe, that such immense motion can exist without disturbance, that you can lie still, feel at rest, and yet be traveling through space at extraordinary speed. It reveals something fundamental about how motion works. It is not speed alone that creates sensation, but change, acceleration, shifts, forces acting unevenly. When motion is constant and shared, it becomes silent. And so, your entire life unfolds within this silent journey. Every moment you have ever experienced has taken place along this path. From your first memory to this very second, you have been carried through the galaxy, never stopping, never returning, always moving forward into new regions of space. This gives a new meaning to the idea of a journey. Not something you choose, not something you begin or end, but something you are already part of. A path written into the structure of the universe itself. And it connects back to everything we have explored. Time, as we have seen, is not separate from motion. It emerges from it. It is defined by change. And this vast, layered movement of Earth, of the solar system, of the galaxy, is the foundation of that change. So your experience of time is inseparable from this journey. Each second is not just a tick of a clock. It is a segment of a path through space, a small step along a trajectory that stretches across the galaxy and beyond. And now, as we approach the final part of this journey, the question shifts one last time. Not just where Earth is going, but what it means for you to be part of that motion. Because when everything is always moving, when every moment carries you forward through space and time, the idea of stillness becomes something entirely different. Not the absence of motion, but the quiet experience of moving together with the universe itself. At the end of this journey, we return to something that once felt simple, the idea of being still, of resting, of pausing, of existing in a single place without movement. But now that idea has changed, because you have seen what lies beneath it, the constant turning of the earth, the orbit around the sun, the drift through the galaxy, the motion layered upon motion, carrying you forward every second of your life. You have never been still, not once, and yet you have always felt as if you were. This is not a contradiction. It is a kind of harmony, a balance between movement and perception. Everything that matters to you moves together. Your body, the ground, the air, the world around you all share the same motion. And because of that, the movement disappears. It becomes invisible, silent, something you do not need to notice. Stillness, then, is not the absence of motion. It is the absence of difference. It is what you experience when everything moves in unison. And there is something deeply calming about that. The realization that you are not being carried alone, not drifting through space as a separate object, but moving as part of a larger whole. The Earth holds you, the solar system carries you, the galaxy guides the path. You are not lost in motion, you are supported by it. Each day, as the planet turns, you are gently brought into the light, then back into darkness. Each year, as Earth leans and shifts, you pass through cycles of warmth and cold, growth and rest. And across your lifetime, you travel unimaginable distances, not by effort, but by simply being here. There is no need to chase the motion. It is already happening. And time, which once seemed like a steady flow moving past you, now reveals itself as something different. It is not something you stand within while it passes. It is something that unfolds with you, created by the changes you experience, shaped by the path you follow through the universe. Each second is not just counted. It is lived. It is a marker of motion, a reflection of change, a small piece of a much larger journey. When you think back on your life, you may remember moments as still images, snapshots frozen in memory. But in reality, every one of those moments was part of this continuous movement. Every memory was formed as you traveled through space, carried along by forces far beyond your awareness. And that journey has no true repetition. The Earth never returns to the exact same place. The galaxy never pauses. The universe continues to expand, to evolve, to shift in ways both subtle and vast. So even as your days feel familiar, even as routines repeat, you are always somewhere new. There is a quiet comfort in that idea, the sense that life is not a loop, but a path, that each moment, no matter how ordinary it feels, is part of a unique trajectory that will never occur in exactly the same way again. And yet, within that constant change, there is also continuity. Patterns return. The sun rises. The seasons cycle. The night sky shifts in familiar ways. These repetitions give structure to your experience, even as the underlying motion carries you forward. It is a balance between the familiar and the unknown, between repetition and progression. between stillness and movement. So tonight, as you rest, as your body relaxes and your thoughts begin to slow, consider this gentle truth. You are moving, not in a way that demands effort, not in a way that disrupts your calm, but in a quiet, continuous journey through the cosmos. The earth beneath you is turning, the planet is traveling, the galaxy is drifting, and you are part of it all. There is nothing you need to do, nothing you need to follow. You are already on the path, and perhaps that is what stillness truly means. Not stopping, but trusting the motion, letting yourself rest within it, letting the vast, invisible currents of the universe carry you, just as they always have. And as the night deepens and the world grows quieter, that motion continues, steady and unbroken, guiding you gently forward through space and time, into moments yet to come. If you're still here, still listening, softly leave a 3 in the comments, and let yourself drift a little further into that quiet, endless journey.